You know, for as long as we've had computers, we've dreamed of controlling them with our minds. It's always been pure science fiction, right? Well, not anymore. In 2025, that fantasy just became a verifiable scientific fact. We're talking about a direct line, a real communication channel from the human brain straight to an AI.
So let's just ask the big question right up front. Is it really possible? Can we truly bridge that gap between our own internal world of thought and the external world of code and machines? Can you just think a command and have an AI actually get it and then do it?
The answer, as of right now, is a resounding, unequivocal yes. And I want to be super clear here. This is not a prediction. This isn't some far-off future. The breakthrough is already here. The results are in, and they are absolutely revolutionary.
So just how real are we talking? Well, check this out. Researchers at Keio University in Japan have already hit 79% accuracy in real time decoding a person's intention directly from their brain signals. And we're not talking about a simple yes or no. We're talking about the specific intent to do something, like, say, like a post on a social network. Incredible.
Okay, so let's really dive into this because this is where the story goes from amazing to truly mind-blowing. We're officially moving past theory and into concrete, peer-reviewed science that is happening as we speak.
So that 79% number comes directly from this research. The key phrase here is LLM-based decoder. Now, an LLM, a large language model, that's the same kind of AI that powers systems you might have used, like ChatGPT. But here, it's being put to a totally different use, interpreting the incredibly complex, noisy electrical signals from the human brain. And it's doing it with stunning accuracy. And listen, this isn't just one lab getting lucky. What we're seeing is a genuine global convergence of neuroscience and AI. You've got leading institutions all over the world, from Japan to China all the way to the United States, and multiple teams are all reaching these same kinds of groundbreaking conclusions, independently. This isn't just a new paper. This is a full-on scientific paradigm shift.
So how in the world does this magic trick actually work? Well, the secret is all about having a brand new kind of translator, one that can speak both the language of our neurons and the language of silicon.
First off, the basics. The tech is called a brain-computer interface, or BCI, and it's pretty much what it sounds like. It's a bridge, a system that lets your brain talk directly to a device, completely skipping the need for your hands, your voice, any physical action at all.
Now, your brain, right now, is buzzing with electrical activity. The simplest and safest way to listen in on that activity is with a non-invasive EEG cap. The best way to think about it is like this. Imagine your brain is broadcasting unique radio frequencies for everything you think about doing. The EEG cap is the sophisticated antenna that can pick up those specific signals.
So here's how it all comes together. First, that EEG cap reads your brainwaves, but those signals can be a little fuzzy on their own. So to get more context, the system also pulls in other data, like where your eyes are looking. Then, and this is the big breakthrough, the large language model doesn't just look for a simple pattern. It actually infers what you're trying to do from all that data combined. And finally, that inferred intention gets translated into a direct command the AI can execute.
And that right there is the absolute game changer. See, older systems really struggled because brain signals are just so complex and ambiguous, but an LLM is a master at understanding context. It can look at a fuzzy brain signal, combine it with your eye movements, and basically reason, okay, they're looking at the like button and their brain is firing a motor intent signal, they must want to like that post. It's incredible.
And you can just see what a massive leap this new approach is. Older AI models like these CNNs you see on the chart are purely data-driven. They need tons and tons of your specific brain data just to learn your personal patterns, but the new LLM approach is knowledge-driven. It already knows so much about human language and logic that it needs way less training data to hit a much higher level of accuracy. It's just smarter, right out of the box.
All right, so we've covered the how. Now for the fun part. Let's talk about the what. What can you actually do with this technology, like today? So let's start in the digital world. The Keio University study showed that participants could take precise control of everyday apps. We're talking browsing a social media feed on X, selecting a specific post to read, and even liking it, all just by using their thoughts, by imagining the action without lifting a single finger.
But this doesn't stop at the computer screen, not even close. Research out of the East China University of Science and Technology proves this extends directly into our physical world. Their system lets users operate robotic arms, fly drones, and even control a smart home. We're talking lights, air conditioning, the whole 9 yards, all through this BCI powered by an LLM.
And you know, because a large language model is at the heart of this, the whole thing is naturally multilingual. That system from East China, it supports over 10 languages. So a user can give a command in Chinese, English, Spanish, whatever, and the LLM just gets it. It instantly understands and creates the right interface. This makes the technology globally accessible from day one. It's a huge deal.
So, when you start to put all these pieces together, it becomes really clear we're not just looking at some clever new gadget. We are witnessing the actual dawn of a fundamentally new era of how we interact with AI.
What are the real long-term implications here? What happens when that barrier between our minds and our machines starts to dissolve?
Well, the impact is just immense. First and foremost, for accessibility, this is completely life-changing. It offers people with severe motor disabilities a powerful new way to communicate and control their environment. Beyond that, you're looking at a new form of human augmentation, a faster, more seamless way for pilots or surgeons to control complex systems. And ultimately, it just creates a deeper, more intuitive partnership with AI, where technology can finally understand our intent directly from the source.
When we look back, there's no doubt about it. 2025 is going to be seen as the inflection point. This is the year that brain-computer interfaces, supercharged by LLMs, finally made the leap from a laboratory curiosity to a practical, demonstrable reality.
So this technology is no longer a question of if, it's a question of when and how. The boundary between our minds and our machines is getting blurrier by the day. And while that opens up a world of truly incredible possibilities, it also raises some really profound questions. Are we ready for what's coming next?